我先介绍，给刚才没有去上一个session的人介绍一下 Pamela Fox。他是在 Google 的那个悉尼工作，然后呢，主要是在 Google 的技术推广部门，推广呢地图 API 的使用，然后呢，就是他自己也参加了，也写很多代码，就是利用 Google API 做一些 mashup， 做一些 example 之类的。然后这次呢，我们很高兴他能够从悉尼来到北京参加我们的 Google 的开发者日。他本身也是非常有经验的 API 的使用者之一。So let's welcome Pamela to start the session.
All right, hey guys. So it sounds like a lot of you were just in the last session. So I have to admit there is a part of this presentation that is somewhat redundant with the last session. So I'll just go really fast through that, and that'll be like review, and then we can have a quiz later to see how well you did. So what I'm going to be talking about today is performance tips for Maps API mashups. I've been the Maps API support engineer for the last 2 years, so I very often get questions about how to make maps load faster. And this is common because we're kind of crazy for taking maps into the browser, especially as early as we did, because the browser traditionally wasn't a very powerful thing, right? Because remember the browser, originally the coolest thing it could do was a blink tag, which is still the coolest thing. But still, it's hard. The fact that we brought maps in the browser means we're really putting the browser, we're kind of challenging it quite a bit. So sometimes you run into problems where what you're trying to do is just too slow. So we're going to look at ways that you can speed up your mashups. And the reason is because the faster your web page is and the faster your map mashup is, the happier your users will be, right? If the web page loads fast, the more they'll use it, and then the more, pizzas they'll buy or ads they'll click on or whatever it is that your website's trying to do. Nobody wants to use a slow website. So this is like a core motto at Google, and we want to make sure that it's important for you guys as well. So the first thing I was going to talk about is loading the JavaScript API, and we've kind of already just talked about this in the last session. So we'll just go through this fast. JavaScript API, it's slow to load in all those resources. We spend a lot of time loading stuff in, loading tiles, etc. It gets even slower on the mobile devices. It gets slow because of the fact that for a given viewport, we're loading in 9 tiles instead of 1 image. It gets slow because we have such a massive API. Here you can see all the classes that were added to the API after I joined the job 2.5 years ago. So we basically doubled the size of the API. And we tried to modularize. It didn't work, so we introduced Maps API v3. So you guys were all, I think, in the last session, so you know all about v3 now, and it's incredibly latency oriented, and that's the most important thing. And we've modularized everything as much as possible and gotten it to work well on mobile devices as well. So we're hoping in the future, we designed it for mobile, but there are people that want fast loading websites on their desktops as well. So once it's stabilized, we want everyone to be using this for all their desktop websites as well, because a user isn't going to complain that you made the map faster, right? They're only going to get happier. So this is our solution for the problem of loading the JavaScript. All right, so here's a very common problem. Oh, actually, summarize very quickly.
OK， 我想大部分人也都参加过上一个的session，所以我也不需要在这里多说。就是前一阶段主要讲的就是说为什么地图会比较慢，就是 API 会比较慢。当然，最主要原因是因为地图这样一个很复杂的一个 AJAX 应用，在以前的 browser 时代是不可想象的。然后出来以后，对于 browser 的要求提高了很多，所以呢，并且有很多的文件需要 load， 所以会比较慢。然后呢，我们解决。在现在这个阶段，我们非常想把 Maps API 能够在手机终端上能够使用，因为手机是移动的互联网，是互联网的未来。然后呢，我们就发现这个 latency 有一些问题，然后我们就推出了 Maps API v3， 希望通过它能够解决就是手机上使用 Maps API 的一些问题。
All All right, now for new stuff. So a really common post in the forum, in the Maps API group is, hey, I tried to put 10,000 markers on the map and it was really slow, right? Well, it's because 10,000 markers is kind of a lot. But many people have a lot of data points that they want to visualize and they can't figure out the best way to do that. And the reason that 10,000 markers is slow is that markers weren't designed to have 10,000 on the map at one time. So remember that the JavaScript Maps API v2 is based off the same JavaScript that powers maps.google.com. So every feature in the v2 API is based off features that we designed for Google Maps, the consumer product. So if you think about Google Maps, when you do a search, you get back 10 markers, right? So we designed these markers so that 10 of them could be displayed at a time, not so that 10,000 could be displayed. And we also designed them to have a lot of features. We designed them to be printable because we wanted people to be able to print maps. We designed them to be draggable so you could edit the markers. We designed them to be clickable in every browser, including IE6, and have a perfect hotspot around it. So all of these features mean that, in fact, gmarker objects are huge objects and can contain up to perhaps six different DOM elements to create one marker so that it has all these features. So you can see some of the features here when you create an icon. So the basic point is that gmarker was designed to have a few of them on the map at a time and was designed to have a lot of features. You may not need all those features. You may simply want to have 10,000 visual items on a map. So the solution here is to create your own marker class. So luckily in v2 and v3 we have an overlay class that you can extend and create your own overlays. And basically all you do is say, all right, here's my overlay, and when you put this overlay on the map, I want you to draw this div and color it this way, right? And when the map moves, I want to reposition the overlay so that it's here. All right, so in this example, let me show this. So here's a little comparison text. So we'll add 500 gmarkers. All right, and so it actually loaded pretty fast because I'm in Chrome. Let me clear these. Let's add 1,000 marker light. And there we go. So I got twice as many in, I think, a little bit faster amount of time. If I was in a different browser, you'd probably see even a bigger amount of difference. So these are very simple markers. They contain a div and then an image node inside the div. In fact, I could have optimized these even more. I could have had a div and set the style to be a background URL of an image. So that would give me only one DOM node. So think about it this way. Your goal is to reduce the amount of DOM nodes in your application at all times. DOM nodes are what makes browsers slow and what makes map panning slow. So I could optimize even further by doing a div and just setting the background color to some hexadecimal thing or to red or something like that, and had no image at all. So that would be kind of taking this idea to the extreme. Now, you can go even further than this, and we have a few customers that have. So Redfin, they're a real estate website, and they wanted people to be able to see many, many houses on the website at once. So we'll go and look at that. We'll do Firefox this time. So here, searching in San Francisco, I can change my search options. Let's assume that I have $550,000 to spend, which I don't. You can give me it. So I'll do a search here. So right now it's just doing a call to the server. But once it actually gets that call to the server back, it loads 462 results on the map really, really fast. So it's a matter of milliseconds there for actually showing them on the map. So they've just taken the idea of mine a little bit further. All right, so they're creating a custom overlay as well, but it's a bit different. Their custom overlay actually contains every single div inside of just one overlay. So instead of having 500 markers on the map, they have one super marker, and that super marker contains all of the divs that's needed to represent the houses. So this means just a lot less redrawing by the Maps API. And basically means that you control the redrawing and you can optimize when it gets redrawn when the map pans. So first thing we do is construct our supermarker. And we're going to have a layer which is going to be a div and hold all the marker objects. And then we're going to extend the GOverlay class. If you're doing V3, it would be overlay view class. And then we have the initialize function. So all this does is creates a div, appends it to one of the panes. So there's multiple panes in the Maps API, so you can append it to whichever one you think is appropriate. Here we're appending to the same pane that markers get appended to. And then we're going to call the redraw function. So that function calls draw, and what we do is we iterate through all of our marker information and convert the lat longs to pixels, and then we're going to just go and push divs at those pixels into basically we're creating a giant string of HTML, and then finally once we have this giant string of HTML, or actually array, we're going to set it to the inner HTML. So there's actually multiple things that are going on here that makes this faster. First of all, we have the fact that we're putting all the divs into this one div. That's an optimization. But then there's just stuff independent of maps. So if you're doing string concatenation, don't use plus equals. It's actually slower in a lot of browsers. A better technique is create an array, push a string onto it, and then at the end just join that array with whatever you need. So you'll get better performance that way. The other thing is to not use DOM techniques, to not do document.createElement, element.style.blah. That actually can get really, really slow, especially for 500 elements. So instead, constructing an inner HTML string tends to be a lot faster. And then he doesn't show it here, but he is doing a background URL in order to set the images for this. So those are some general techniques which can get you just very, very fast performance. So then to actually use this, what he does is creates a new supermarker, adds it to the map, and then he just creates a JSON that contains information about all the markers that should be drawn into that one supermarker. So that is, I showed you that in JavaScript. We also have a Flash API, which I haven't mentioned yet, but we did come up with the Flash API last year. Works in Flash, works in Flex. And the Flash API does tend to be better at performance, but even Flash has the problem that it has a DOM, and the more stuff you put into this Flash DOM, the slower it gets. So people have come up with the exact same technique in JavaScript for Flash and got it to be really fast. But I need an internet to make it work. I can try. Okay, so here we go. Yay. So this is Flash, and you can see there's, I don't know, thousands and thousands of markers here, and I can still mouse over them. I can still get tooltips. I can click on each individual one. And just really, really fast performance here. No problems with panning. It loaded really fast once I reloaded, and we still have full interactivity. So you can see that you can just get, you can actually put quite a bit of markers on the map if you optimize what your marker class looks like. All right, so even with this technique, if I tried to put 10,000 into that supermarker class, or if I tried to do 10,000 marker light, I might still have the issue of it being too slow. Because even after optimizing marker, I still have at least 10,000 DOM nodes that are being placed on the map. So how do we go about restricting the amount of actual markers that are being created? So one technique is to cluster. So let's look at this example. So this is Author Mapper, and they show a couple classic examples of clustering. First of all, you have individual markers that indicate there's one point here. Then you have multiple markers that indicate there's a group of points here. And then you have some way of indicating the cluster size. So in this example, they have this legend that says that the more red it is, the bigger that cluster is. So I know that this cluster here is actually quite big. And then as I zoom in, the clusters expand out, and I get individual clusters here. So that's a classic clustering technique. The basic point of clustering is that you're reducing the amount of points that have to be shown on most zoom levels. And then once you get in, there's only, 30 points shown in this particular viewport. So you've gotten good performance just by not having it so that there's ever 10,000 of those points on the screen at a time. And the user can still click down and zoom in to actually be able to click on those markers. So they still can drill down to the information they need. It's just a different way of navigating it. So there's a couple different ways of doing clustering. One way is to do it on the server side. So this one loaded here. So this example here, they have all their data. This is for mapping panoramas around Europe. So they have a lot of data, and basically every night or every week or something like that, they run the data on the server through a clustering algorithm, and they figure out what the clusters should be for all of these markers, and then they have a database that tracks all the clusters, right? And then in the JavaScript, all they do is query the database for the clusters and create the cluster markers. And then you can see some slight differences in the UI here. They use numbers on the top to indicate how many panoramas are there. And then when you mouse over, it gives you the option to zoom in and expand out. So server-side clustering is great, but because you'll get really good performance because you're not doing any calculation of how to cluster when the user is looking at it, right? But it's also kind of hard because you have to go and write a clustering algorithm. And not everybody wants to deal with that. Not everybody wants to have to worry about running clustering every night or storing clusters in their database. So in that case, there is actually the ability to do client-side clustering, and there's a library called Marker Clusterer that we just released that will do this for you entirely in JavaScript. And where's the author? Is he here? Yeah. Okay, so he actually wrote it. So if you have any questions, you should talk to him. So this will do clustering for you entirely in JavaScript. And it uses a fairly simple algorithm, simply divides the world up into a pixel grid, right? So the default would be 80 pixels by 80 pixels, and says, all right, there's that grid square, there's that goes there, that goes there, that goes there, that goes there. So yes, it's very simple, and it's not as maybe sophisticated as something like a k-means clustering, but it works, and it works entirely in JavaScript. So it's a really good technique to try out. So you can see here's the example. So we've got color. We're using color to indicate size of clusters, and we're also putting numbers on top to indicate how many are there. And then you can see our individual markers are the blue ones here. So to use this, it's actually really easy. We create an array of markers, and then we just pass them into the marker clusterer and pass in the map, and then it does everything for you. It is an open source library, so you can tweak it to your heart's fancy, and have it do other things. There's somebody right now who's working on making it so instead of showing the number of markers in each cluster, it's showing the average intensity. So you'd assign an intensity value to each marker, and then it would calculate the sum for each of the clusters. So that's the kind of modification that you could make to this. And you should talk to him after if you want to use it. All right, so that is kind of clustering based on some sort of things that you figure out algorithmically, whether it's a complex algorithm or a simple grid-based one. You can also do regional clustering, since we are talking about the world, and conceptually, we have divided the world up into regions, and so we somewhat know what these regions are. We've agreed upon them across the world. So let me show. I walk too much. So here's Traveler. They're kind of like Yahoo Answers, but for maps. And they're doing regional clustering, so if I mouse over each of these, you can see what each of these clusters represent. And then you can zoom in, and at this point they'll do countries, and then they'll do regions as well. And then if I zoomed in here, they'll do cities, as well as those regions there. So this, I think, it's a really nice example, and I love how when you mouse over, it actually shows you the name of the region. The only thing that I would want to add to this is actually showing the polygon that represents that region when you mouse over, because it's a nice touch for the user to actually see what a cluster represents. There is an example that does that. Some of my examples will not load right now due to, stuff. So this example just shows when you mouse over each of these clusters, it'll actually highlight the United States the state and show you the polygon border. So that's the kind of thing that would nicely be integrated into the traveler map. So with regional clustering, you can do this if you actually know what regions are associated with each of your data points, right? And if you actually know for your particular area that your map covers what the region hierarchy is. So maybe in China, you guys have provinces, right? Right, so you might start with China and then go down to provinces and then go down to, you have districts as well and cities, so cities, districts, etc. So it might be kind of nice if, one of you guys made that and then shared it with everyone. So that'd be something that you could do for a China Maps mashup. Here's a couple more resources. There's an article that compares a bunch of the client-side marker clustering algorithms. There's some Python code for doing k-means clustering if you guys want to do it on the server. And there's Maptimize, which is a hosted clustering algorithm where you give them the data and you pay them a bit of money, and then they'll run the algorithm on their server and then give you some JavaScript to use later. And all the slides will be available after the conference, so you don't have to memorize every URL that I show. But if you want to take pictures, you can. All right, so clustering is really good when you want your users to eventually be able to click on the information and drill down, but sometimes that's not necessary. Sometimes you only care about the users visualizing the distribution of your data, right? And you don't care that they're not able to click on every single point. So I call that view-only visualization. Here's an example that won't load now, but basically they geocoded the campaign contributions for everyone in the United States, and then they burnt those into a tile layer, so into images. So every dot there is somebody who contributed to a campaign. And so you see the red represents Republican, blue represents Democratic. So you can immediately look at an area and get a feel for whether it's largely Democratic or Republican or where the different clusters are and where it's mixed. And they'll show you a sidebar that has a sampling of contributors from the area, but you can't click and then see something pop up. So this is fine because this is just, people want to see this, they want to see the data. They don't care that they can't click on an individual pixel and open it up. They just want to understand what this data generally looks like. So here they've rendered the images on their server and then serve them as a custom tile layer. So this takes a bit more effort from them to actually render the images, but when you have, I think they had, gosh, I don't know, millions of dots to visualize. When you have millions of dots to visualize, this is a pretty good solution. Another thing you can do, which is similar, is a heat map. There we go. So this is a heat map. Oh, I just moved it. This is a heat map for pizza in Boston. So this is a good way of visualizing density of information again. So this shows us that if we wanted to get pizza in Boston, we would go to the center of that heat map and we would find the most number of pizza restaurants here. So heat maps are nice, and there actually is a heat map API that you can use, and there's a few open source projects for rendering heat maps. But just keep in mind when you're using heat maps that sometimes they can be deceiving to users, and users don't always interpret heat maps the right way. So you should make sure that when you're using the heat map that it actually represents the information correctly. All right, so final thing I want to show you is kind of a compromise between the two. So I showed you clustering, which you could use to have clickable stuff, and I showed you this density mapping, which you could use just to visualize the information. But on Google, Google Maps, we actually found a compromise between the two. We'll see if it actually loaded. Ah, sweet. All right. So it used to be that when you searched, you only got the top 10 search results. But this was really confusing for users because they'd say, hey, I know there's more than 10 search results. I don't want to have to paginate through. I just want to see all of those search results at once. So we wanted to figure out a way to be able to visualize every single search result, but still have the map be usable, right? So what we did is that we created these, we call them pimples, like measles. These pimples on the map, and each of them represents a search result past the first 10. And we can click on them. And it'll open up an info window for that result. Slowly now. So each of these results are clickable. So the way we do this, these are not tiny markers. These are actually tile images that we've made clickable. So let me see if I can show you the Firebug. Do you guys all use Firebug? Firebug? Yeah. All right, sweet. Cool. Okay, so you can kind of see it here. So what we have is we have these tile images. Let me see if I can show you what one of those looks like. Images. So here, you can kind of see it right there. Let me show you in the tab. Okay, so we've rendered these pimples into tiles. We overlay those tiles on top. And then to make them clickable, we pass down some JSON information. So going back to here, pass down some JSON information that tells us the clickable pixel bounds of that tile. And then every time you're mousing over, we check to see what pixel bounds the mouse is within. And we check to see whether we should change the cursor. And then when you click, we check to see which one you're in. And then we just do an AJAX call and open the info window for that particular piece of content. So you can see pixel bounds and then an ID. So that's all we need. Once we have the ID, we can open up the correct info window. So the thing to know about JavaScript is that JavaScript is actually very fast at checking what's inside a bounds, right, like a pixel bounds or even a polygonal bounds. So this is actually really, really fast. You might say, oh, but it'll be too slow to go through all of those pixel bounds and figure it out. But no, JavaScript is good at math, bad at DOM. Well, the browser's bad at DOM. And JavaScript's getting faster and faster. I mean, we helped with the whole Chrome thing, but other people are getting faster too. So this is how you can create clickable tile layers. Now, here's an example. No, not that one. Here's an example where a developer did it a slightly different way. You can see as I mouse over, these little dots are clickable. So once again, all this is a tile. There are no markers here at all. What he's done is really clever. He didn't want to have to pass down both tiles and JSON separately. He wanted to reduce the number of requests. So he's attached the pixel bounds information as cookies to the tiles, and when he gets a tile in, he strips off the cookies, figures out the bounds, and then adds them to his global bounds array. So then with simply one request, he's got all the information he needs to make a clickable tile layer. So I think this is an awesome hack, and everyone should do it. So this solution is nice if you're kind of in between the whole heat map thing and in between the clustering, and you have the ability to actually render tile layers. You might think about doing these clickable tile layers because basically it'll scale up to any amount of markers that you put it in, right? If I did a local search for pizza and there were 1,000 markers that time, I would have the exact same performance as if I did a local search for Mexican food, which we don't have in Australia. Okay, do you want to summarize?
这一节的话，我想主要讲的就是说，大家会经常碰到一个问题，就是要在地图上放很多的那种小 marker 在上面。很多使用 API 的朋友都向我咨询过这个问题。然后这一节主要就是讲怎么处理。放很多 marker 主要有2个困难在上面，一个就是说你放 marker 上面每一个 marker 都需要至少有5个 download 来完成这样一个 marker 的绘制。然后这里提出的解决办法就是说，你自己去继承 G overlay， 然后通过那个减少需要的资源的数量。比如说你对一个 marker 的话，你只 download 1个 image 就可以了，不要去 download 5个 image。这样的话，对于 browser 来说，你就可以只用原来1/5的 HTTP 连接就创建一个 marker， 这样的话显然会变得比较快。然后第二个的话，第二个碰到的困难就是说在 browser 来处理 DOM 的操作是很慢的一件事情。然后怎么做呢？提出了几种解决办法。首先当然是做 cluster 意思是说，你不要一次显示所有的那些你要加的 marker， 你在不同的 zoom level 显示不同数目的 marker。当用户继续向下点的时候，到一定的比较 detail 的时候，你就显示更多的 marker。这样的话，好处就是说你可以减少在地图上需要加的那些 DOM 的数量。 并且我们着重提到，就是说现在有很多可以使用的一些成熟的类和算法，其中有一个是我们在这里做的小西同学开发的。然后大家如果有什么相关的技术问题，可以直接找小西。然后对于 cluster 的话，当然还提到不光是你可以在 browser 里面通过 JavaScript 做 cluster， 也可以在服务器端做好了以后，然后直接在browser 就是想发出请求的时候直接就显示就好了。除了 cluster， 然后另外我们提到的一些解决办法就是说，你通过一些视觉上的一些变化，不要只是想显示所有的 marker， 可以通过比如说 heat map， 就是说通过不同的颜色来标识地图上不同的区域，然后显示这个地方信息的那个密度有多少，这也是一种方法，并且也有现成的 API 是可以用的。然后到最后提到的就是说，你可以画自己的 tile， 就是画自己的底图。刚才提到我们 Google 的话也使用了这种方法，就是比如说刚才讲的那些点，实际上最后在 Google 的 server 上我们都是把它生成了一个那个 tile， 然后通过叠加 tile 到现有的地图上面来实现刚才你们看到那些通过一个 search 然后有很多点点在上面的那种效果。但是 tile 的话，它的问题就是说你是没法点的，因为它是一张图片，它只是两个图片叠加起来，然后你没法点的信息的话，Google 的解决办法是说通过另外一个 HTTP 请求，把当前这个 tile 对应的可以点的那些 line long， 然后又传到那个 browser 里面，然后 browser 就可以进行计算，知道在哪个区域我是可以点的。当鼠标移到那个地方，它会变成手的状态，然后点的话，你就可以响应一个相关的操作。这样对于 Google 来说，我们就提供。对于一个那种 search 的那种页面，我们首先要提供一个 tile 的请求，然后还要提供一个那个 JSON 的有关那个 location 的请求。另外一个就是有个第三方做那 clickable tile layer， 它是用一种更巧妙的办法，它就是说发 tile 的时候，它把那些点的信息直接加到 cookie 里面，然后这样一个请求里面又有 cookie， 通过 cookie 就保存了那些 tile 的可以点的信息。然后呢，它返回的还是一个 image， 这样的话，你一个 HTTP 请求就可以达到这些效果。
All right, thank you. All right, so this is very similar to the last issue, is trying to render lots and lots of polygons or polylines. All right, so we actually have the same problem that we had with gmarker. Gpolygon, gpolyline were both created for Google Maps, so they have lots of features. And they may not be all features that you want, but it does make it slower, right? So we do, they're editable, they have fill and stroke, we do bounds clipping, we do all these things to the gpolygon, which may make it so that it's slower when you want to load lots and lots of them. So one solution here is to make your own polygon class. This is a little bit more difficult than creating your own marker class because you actually have to, draw vertices inside a shape. But luckily, people have done it for you. So there's a great library called Polygonzo. This demo won't load right now, but if you need the code, I can send it. But it's really good, and it has a great demo which actually loads, 34,000 points and 3,200 shapes. And you can click animate, and it will change the colors every like half a second or so, which is absolutely amazing to me. Now behind the scenes, what this uses is Canvas in all the browsers that support the Canvas tag, and in Internet Explorer it uses VML, but it uses a really, really fast hacked version of VML to try and get it as fast as possible. So the developer who made this, that was the developer that was making our election maps. Where we had to try and visualize all of the voting districts in America. So he was constantly dealing with the problem of trying to display lots and lots of shapes on the map. So he came up with this library to solve it. So I recommend this library as the best way to actually create a custom overlay that does polys. And it's open source, so you can take it, tweak it, use it. Now, even if you're managing to use Polygonzo, you still might have the problem of having way too much points in your data. And this is very common for Polygon and Polyline data because oftentimes you get it from sources that don't realize that you want to use it on a 2D map eventually on the web, right? So you might get it from a shapefile or from some GIS data, and it just has a huge amount of points because the people, they go outside and they form a shape every 2 feet and then they give you absolutely every point that they've recorded. You don't need all those points for the maps, right? You just need enough points so that the user can see what's going on, right? And this can vary for every place. So you can see Alaska actually has, like 10 times the amount of points of all the United States combined, just because it has all these crazy little islands and stuff like that. So you have to worry whenever you're displaying geographic data, because countries are just shaped really, really weird. Like if it's up to me, we would just take the world and divide all the countries into squares, and that would make maps so much easier to make. But I don't rule the world, so I just get talks instead. So what you want to do is simplify your data before you ever show it in the browser. And there's a couple algorithms you can use. Main one is the Douglas-Poiker algorithm. And there's code for running the Douglas-Poiker algorithm in basically every language out there. Java, Python, Perl, whatever. So basically what you do is once you got your data on the server, you'd want to run it through one of these algorithms, get back simplified data, and then use that in your mashup. This thing here actually will let you see the effects of simplification live, just so you can understand what's actually going on to your code. So the algorithm will try and remove the points that aren't really don't really make as much of a visible difference to the user, right? Now, there's also the thing where you may have a lot of points that you want to show when the user is zoomed into a line or a polygon, but you don't need to show as many points when they're zoomed out, right? So if they're zoomed out at level 6, then we only need 10 points. When they zoom into level 16, then we need 300, right? So we wanted to make this easy for Maps developers to optimize like this. So we created encoded polylines, which means that you can create an encoded polyline, and inside the encoded string, it will actually specify which points get displayed at which zoom levels. So you can just give us the encoded string, and we'll do all the figuring out of which points to show for you. You just have to run your poly data through the encoding algorithms and give us back the string. So this is really good because this is kind of like clustering, right? Clustering where it's the same amount of data, but you're representing it a different way when you zoom out, right? So here we know that once we zoom in, we're never going to see that many points on the map at one time. So it's okay that there are more vertices in the whole polyline, right? Because we do bounds clipping. So even if there are more points outside this polygon, we're only going to be rendering on the map in the DOM the ones that are in this viewport. So we're optimizing to show the least amount of points per viewport. So it's very similar to clustering and has the same effect. So what you need to do here is, if you want to use encoded polylines, is to run your polygon data through an encoding algorithm, and there you can get it in any language, and then just pass the information to us as an encoded string. Let me see if I have that one loaded. Oh, here we go. Let's see if I can show you the code for that. All right, so this looks kind of nasty. This isn't encoding, so encodings tend not to look that good. But you don't have to handwrite this. That'd be hard. So basically what we're doing is just creating a polyline, and the first thing here specifies the points. The second thing specifies the zoom levels for each of the points. Right? And this is what an encoding polyline algorithm will output for you. And you just have to pass that back into the API. So here it's this new G polyline. And this site that I'm on right now, this site has all of the different code for doing the encoding in lots of different languages. So it's a really good site. All right, so you've done all that, and you've optimized as much as you can, but you still have the problem where your maps work great in some browsers, but are still kind of slow in other browsers. And this, unfortunately, is always going to be a problem if you're trying to use vector graphics from HTML. Because the thing is that browsers have not agreed on how to do vector graphics yet, so we don't have one way of doing it. So basically we have SVG and Canvas, which are two ways that are generally supported actually by both Firefox and WebKit, Safari, Chrome. And then we have VML for IE. So unfortunately, IE is being mean. and it won't support SVG or Canvas. So this means in the Maps API, when you create a gPolygon, we're actually looking at the browser and saying, oh, okay, all right, it's IE, we're going to use VML. It's Safari, we're going to use Canvas. It's Firefox, we use SVG, right? So in every browser, we have a different technique to choose because we have to look, and we constantly run tests and figure out, okay, like for IE or for Firefox and Safari, which is faster for this browser, SVG or Canvas? And it changes all the time, and it changes per operating system. For a long time, SVG on Firefox was too slow, so we actually had a graphics server that would render images and overload those as tiles. So it's a really hard problem right now, and our hope is that eventually IE will support anything that anyone else supports, and then we can have one consistent way, and then you'll have hopefully largely consistent performance across the browsers. But until then, you'll always need to test your polys in multiple browsers and see if the performance is bearable. You could always put a warning on IE6 that says don't use this browser, but not everyone likes to do that. So a solution here is if you don't want to deal with the fact that browsers haven't agreed on how to do vector graphics in JavaScript, don't use JavaScript, use Flash, right? And the Flash actually is really good at doing vector graphics natively because it's somewhat what it was designed for. And the great thing about it is that once it works in one browser, you're going to get the same performance in another browser. So that one won't load right now. All right, so but basically you'll get great performance, and this example here actually compares the exact same thing in JavaScript to Flash, so you can see for yourself how well it performs. You can see in Chrome, you can actually barely tell the difference because Chrome, like Safari, supports Canvas, and Canvas is actually really fast. That's what that Polygonzo library is written in. But when you go to IE, you'll actually see a much bigger difference between JavaScript and Flash. So Flash will give you consistent poly performance. So I know a fair amount of people are moving to Flash because they want to do powerful things and they don't want to have to worry about the browser differences for now. And eventually the browsers should converge and catch up with each other, but unfortunately vector graphics is one of those things that is taking a bit longer. All right, if you don't want to use Flash though, you do have one more solution you could use, which does take a bit more effort, but that is to use tile layers. So this is how we do our stuff on Google Maps. So if we go here, we go get my toolbar on. Images, outline images. All right, so here we have all this vector road data, right? So we're not rendering this on the browser. We're rendering all of this as tiles beforehand. So you can see this here is a tile. So let's go, I could go and zoom in on this tile here. And that tile breaks up into 4 more tiles. And then if I zoom in again, that tile breaks up into 4 more. So this is how we figured out we could pass vector data into the browser, was by just dividing the world up into tiles and just rendering the same size tiles all the time, right? So it means for any viewport you're at, for any amount of road data there may be in that viewport, you're always getting the same amount of tiles. So you're always getting the same performance. So this is ultimately the best way of dealing with vector data in JavaScript, since you'll all have the same performance all the time. So here's an example with rendering out counties. Let's see. Well, this one is basically the same thing. This is the same developer. So all these counties and regions, those are all just rendered into tile images. So no matter what, we're just getting the same performance. It does mean that you have to render the tiles out, though. So that does require some amount of server magic on your side, a server that actually will render images and serve those images to the users. So the thing to know about this is that if you're going to do this, you need a server that can handle creating images, and you also need to think about when you're going to create the images. If you actually were going to create images for zoom levels 1 through 17 for the whole world, you would need a massive hard drive to store them, because the world is really big, especially at 17 zoom levels. So maybe a better technique, if you're going to cover a large amount of space, is just to render the images on demand and then cache them. So then you only render the images for what a user is actually looking at. If you're covering a much smaller area, like maybe you're doing a campus map, you could just render all the images ahead of time for that campus map, and then put them on top of the maps and just serve them statically on your server. So that's something to think about if you're doing this. But it is probably the technique that requires the most amount of work. All right, can you summarize that section?
Yes. 这一部分主要讲的就是说，怎么样能够在地图上加上很多就是很大的那种折线啊和 polygon， 然后里面提到的一些做法，首先当然是说你要简化你的数据，因为你的那些折线在地图上显示主要是给用户看的，没有很多时候一些不必要的点你又不用加上去，简化你的数据，然后提供了一些现成的工具，然后就是说可以用 encoded 的 polygons。这个主要就是说，我们会自动的帮你去决定在什么这样的 zoom level 显示哪些点。当然这个有成熟的算法，并且我们 Google 就是你可以直接用现有的算法。然后就是说，你可以选择不用 JavaScript 来画，可以不用 JavaScript， 可以是选用这些 Vector Graphics 这些技术来画。但是很不幸的是，现在没有一个标准。但是我相信 HTML5 出来以后。这个应该会有标准，大家应该会支持 Canvas。然后后来你可以选择完全不用 JavaScript， 用 Flash API， 这当然也是一个很好的一个选择，因为我们 Google 也支持 Flash API。然后最后的话，这个提到可以自己画 tile， 因为你看到地图 Google 的地图上面提供的也都是实际上是通过 Vector Data， 实际上也可以认为它是 Polygon。但是我们就是说我们不是实时化的，而是在后面通过服务器先把这些图 tile 先画好，然后在用户请求的时候，直接就给一张图片，然后包含了很多的信息，这样就可以了。这样这个技术对于如果有需要的话，你自己也可以用。然后通过 tile overlay 就可以加到地图上面。
Cool. All right, so those are my tips for increasing the performance of your application. And now I just want to talk about something that we haven't talked about anywhere yet. And it's something we're introducing now, which is our developer qualification program. So how many of you are actually Maps API developers right now? Some of you, yeah. So if you're an experienced Maps API developer and maybe you're like a freelance or an agency or something like that, and you want to let people know that you're developers that is maybe looking for work or ready for work, you can do our developer qualification program, and basically you go through a series of steps to get qualified. So there's a test. It's a multiple choice, true, false, that kind of thing. If you miss university, it's great. There's references, so people that you've worked with. There is, if you help out in the community, in the forum, or in the open source library, that helps as well. And then there's also sample code. So using this combination of criteria, we can qualify you. And then we'll have a gallery of qualified Maps API developers. And whenever we get requests, because we get requests all the time, like, can you please recommend someone? Then we can go and point people to that gallery, and then they can find you there. So we're starting this with the Maps API, but we're hoping if it goes well, we'll start doing this with all the other Google APIs as well. So with all the different Maps APIs and with maybe Android and stuff like that. And actually, we do it with the Gadgets API as well right now. So if you're a Maps API developer and you're looking in freelance or agency, then I encourage you to get qualified. All right, and so that's it.
大家有什么问题吗？然后你们可以用中文，我会尽量帮你们翻译。
我就用中文说一下吧。我想问一下，就是在一个层里面，最多可以支持多少个 marker?
The question is how many marker can we support in one layer?
Okay, well, I have this. So with gmarker, I don't recommend putting more than 200 gmarkers on a map. With marker light, you could probably do a few thousand. And with supermarker, maybe, I don't know. I haven't done tests exactly. You can use that page that I did to run your own test, but maybe 4,000, something like that. So probably beyond 5,000, that's when I would look at seriously look at doing clustering or one of the other solutions. And also, even honestly, yeah, you could put 3,000 markers on the map, but it's not always a usable experience. The flash map I showed, that was pretty usable because I could browse and mouse over and see information really quickly. But there are some times where it's not that pleasant for the user, so even if you can technically put 5,000 markers on the map, you should really look at what it's like to be a user trying to use that and see if it's actually a good experience. I would say it would only be good if they were very little and had mouse over properties and actually like raised on top of each other and stuff like that.
Well, it's me again. Okay, in some case, we may display multiple kinds of icons, GMarks, on the same map. And we like to use custom markers. And defining a hotspot on custom markers is kind of complicated. Will you improve it in Wi-Fi?
Right. So that's why I usually do custom markers that are square, because it's a lot easier to make them clickable. If you have custom markers that have a different shape, then you have to go through some amount of effort to do an image map on them. So for gmarker, we have a couple techniques. Some of them is just actually making an area, a traditional image map that defines the clickability. And the other one is supplying a transparent image for IE6. But I think for the most part, the image map technique would work. For the vast majority of browsers, I'd have to check on IE6. So I would strongly try and get you to make square markers, because it's going to make your life a lot easier. And especially if you're putting a lot on the map, I think it actually might make the map more usable, because the user doesn't have to search around for the clickable area. Otherwise, I think you'll have to do the area map. And you mentioned using different images. So that's a good point. I didn't talk about it, but the Redfin, they have different icons as well, because they designate different things. So they sprite all their images together. So all of their icons are in one image, and then they just use CSS spriting to say which part of the image they want to show for each of the divs. So you should, just on an unrelated note, you should do CSS spriting if possible.
Why don't you guys just get rid of the transparent part away?
Sorry, why don't we what?
Just get rid of the transparent part away.
Give it away?
Yeah. I mean, with different shape or different kind of icons, they got transparent parts.
Yeah.
Why don't you just get it away? It's not clickable.
Oh, so are you talking about for gmarker? Or, okay. So I think right now if you do, so you're saying when you create a gmarker, you're getting the default clickable hotspot? Yeah, so yeah, that's if you're extending G icon or G default icon, then you're getting the default hotspot. So I usually override the image map property to just be a square that represents each of the corners to make the whole thing clickable. But you have to have some. I filed a feature request to make it so that when you specify a custom icon, it would set the image map to be a square by default. But we haven't done that yet.
Thank you.
你好，我刚才看到这个片子里面大部分都是在讲那个前面 JavaScript API， 然后 Flash 这边是有几个片子讲了一下。然后我想问一下，像里边那个 encode 还有这个 cluster， 在 Flash API 里边是否支持，以及以后的这个更新功能，对于这两种 API 有没有侧重？会不会说偏重于 JavaScript 或者这个？
So he's basically a Flash API fan. So he wants to know whether we support the cluster and the encoding, the polyline encoding in Flash API. And in the future, will emphasize more on Flash API or JavaScript API?
Okay, yeah. So Marker Cluster is open source, and there is no version of it for the Flash API yet. Somebody just asked about that last week. I don't think it would take very long to port over. I ported Marker Manager over from JavaScript to ActionScript, and it took about 3 hours. All you have to do is go through and change all the function prototypes to say like private function void, and then you go through and add data types to everything. And then, so after you've done a couple search replaces, it's fairly, because we have the interface between JavaScript and Flash is very, very similar. So it's generally really easy to port an open source library from one thing to the other. Especially something like Marker Cluster, I imagine it would be really easy. I just haven't done it yet. And for encoded polylines, pretty sure we have that in here. Polyline. Yeah, so there's from encoded, it's a factory method, and it will take in the points and the zoom levels. So we do support encoded polylines there. And generally with JavaScript API and Flash API, we do tend to have more resources dedicated to the JavaScript API, just because it has a huge amount of users, probably because it was one of the first Maps APIs on the web. If we get more Flash API users, then we can put more resources that way, but we will continue supporting the Flash API for at least 3 years, hopefully more. I really love it. It's what I use for all of my maps lately, because I don't want to debug in IE anymore. I don't care about IE. So yeah, it may not have as much resources, but we certainly don't have any plans of shutting it down. There will always be, at least for the foreseeable, 3-5 years, there's always going to be a need to have a Flash option for doing maps. And there's a lot of times you want to use that for GIS and for advertisements. A lot of people using it for advertisements. Yeah, we're certainly working on it. And the next feature in the Flash API is going to be 3D perspective, so that you can tilt the map and pan and zoom around it. It won't have terrain like that, but it will be tiltable like that. So maybe you can do some interesting things with that. So that should be out in a couple weeks.
Hello, Pamela. I want to know if I want to locate, I want to make a mark that describe the desktop browser's user location. How can I use Maps API to get this way?
The user location?
Yes.
Okay. We had this question a couple times in the last session. So let me remember my answer. So there's quite a few options. On the desktop, if they have an IP and they're not going through a proxy, you can geolocate their IP. You can do this using Gears plugin. You can also do this using client location in the Google Ajax API's common loader. And you may be able to use other libraries as well. If they don't have an IP on the desktop, I think your only option then is to go through one of the different location brokering services. There's FireEagle from Yahoo. So people set their ID with them, and then you can authenticate to FireEagle to be able to take their location, right? So if you have constant users of your application, you could do that. There's Google Latitude, so people can publish their location with Google Latitude, and there's a KML and a JSON feed, and you could tell them to publish their feed and then give them their Google username. So you could use that. There's something called Skyhook or Loki. So there you have to basically, there's these services out there that people store their location in, and you have to get the location out there. You could use their Twitter location. And then for the devices, on the Android, you could use the Gears plugin. It's on the Android WebKit, and that will give you the actual location from the GPS on the BlackBerry, if that's enabled. Otherwise, it would use the Wi-Fi location. On the iPhone, you can use Safari should have geolocation API in it. That's part of the next spec for web browsers, so you could use that. So in short, there's a lot of things you can do. And there's a lot of libraries out there that will wrap every single one of those options into one library, so that you don't have to think quite as much.
我们现在时间只有3分钟，我们问最后一个问题啊。
I see the Map API developer program. It's a certified program. Do you charge a fee for that in any way? The testing or training?
So for the qualified program, to just get qualified, we don't charge a fee, as far as I know. Hopefully it won't take that much time on our part, so that'll be part of our job to verify that you passed the test. A part of this is qualification program is that we are working with third-party training partners, so that if you're somebody who wants to get qualified but isn't quite ready yet, you can go to one of our third-party partners and they've got curriculum that they can train you with. So there you would be paying a fee. The third parties have to make money somehow. But if you learned the API on your own, then we're not going to charge you for knowing it. So there's going to be a blog post about this in the next couple days on the Geo Developers blog. So that should have more information about the third-party training. This is also something we only launched last week.
Thank you. So it's only available in US or online testing?
I'm not aware of restrictions with country. I think at least more than the US because a lot of our gurus are actually from Europe, so I'd be pretty sad if none of them.
But it's completely done online?
Yeah, completely done online. Yeah, it uses Moodle, if any of you guys know Moodle.
Okay, thank you.
Open source learning thing.
So, yeah, that's the last question. We are running out of time. 那谢谢大家，今天就到这里。